this video, let's look at what we have here. We have to calculate the limit of x squared minus 16 over x minus 4 as x tends to 4. Now, how can we do this? It's very simple. I want to show you two ways of which you can solve this very, very easy. I'm going to show you two ways you solve it easily and you will not find it difficult. Now, come close. Now, this is the solution to this problem. Now, if you have a function like this, now let me divide this board. Now, this is the first step. If you have limit of x squared minus 16 over x minus 4 as x tends to 4. Now, this is what you need to do. If you observe here, we can break this in this format of limit as x tends to 4 of what? X squared minus 4 squared all over what? X minus 4. Because 4 squared means 4 times 4, which is equal to what? 16. Now, in mathematics, if you have a squared minus b squared, we can call this difference of two squares. So we can have a plus b to multiply a minus b. So that a times a, we are going to have a squared, a times minus b. A times minus, we are going to have minus ab, minus ab, b times a, we are going to have plus ab, and then b times minus, we are going to have minus b squared. Hope you get. Now, we are going to have a squared, and then minus plus will be eliminated out. We are going to have minus b squared. So you can see this identity here is equal to this. You get. Now, we are going to use this method, this thing I just did now, to apply it here. So we are going to have limit as x tends to 4. Limit as x tends to 4. But in place of this, now we are replacing it with what? X plus 4, x minus 4. X plus 4, x minus 4 divided by what? X minus 4. Now you can see that something is common. This and this are alike, so I will erase them out, cancel them out, and then what I will be left with here, I'm going to be left with what? I'm going to be left with limit as x tends to 4 of what? X plus 4. That's the remaining thing that is left here. Then you substitute the value of x. X tends to 4. So you are going to have what? 4 in place of x, 4 plus 4, which will give us what? 8. So it implies that this limit is equal to what? 8. Now, that's the first method. This method I use here is called the method of direct. What I just did here, I applied the method of two squares. And then after I cancelled out, I applied direct substitution. So it's method of direct substitution. Now, let's come here also. The method I want to introduce to you now is called the Hopital's rule. You get the Hopital's rule. Now, if you have this limit as x tends to 4 of x squared minus 16 all over x minus 4. Now, this rule tells us that we can only apply this rule only when the limit is indeterminate if we use by direct substitution. Now, look at what we have here: x squared minus 16. X squared minus 16. Now, if we plug in this for, we substitute the value of x, which is 4, into here, we are going to have 4 squared minus 16 all over what? In place of x, here we have 4 minus 4. Then 4 squared means 4 times 4, which is 16 minus 16 all over 4 minus 4. Now, 16 minus 16 is 0, and then 4 minus 4 is 0. Now, any function that is divided by 0 is indeterminate, or it is undefined. Undefined, but it's indeterminate. That means it doesn't have an actual value. You get? Now, since we are done it and we have seen that it is undefined, what you are going to do is we differentiate the up and we differentiate the down. That means we differentiate the numerator, and at the same time you can also differentiate the denominator. Now remember, this thing I'm showing you on this part is called the Hopital's rule. This is the rule we are using at this point. Now, if you have something like this, if you differentiate the up here, you are going to have the limit going to have what? X. You get it? Now, remember, no, you are not going to have x. If you differentiate x minus 4, sorry, if you differentiate x minus 4, you are going to have 1. You get it? Now, 2x divided by 1 is the same thing as the limit, same thing as the limit, same thing as the limit as x tends to 4 of what? 2x. Remember, x tends to 4. So it's simply 2 times 4 plus 2x means 2 times x, which is equal to 2 times 4 is equal to what? 8. So you can see that if we use the Peter's rule, we are going to have 8, and if we use the method of direct substitution, after you cancel out your common factor, you are going to have what? 8. And here you also have 8. So you can see this shows the clear solution of this problem. Now take note of this. You can only use the Hopital's rule only when the limit is indeterminate by direct substitution. That means if I should do a direct substitution of 4 into the function, it is undefined or it is indeterminate. That means it doesn't have a value. That is only when we can use the Hopital's rule. But if we substitute into this function and we have a value, let's say a real number, a rational number, or a decimal number, as far as it is not undefined, we will accept the value. But if it is undefined, then we can proceed to use the Hopital's rule. This is just what I have for you today. If you find this interesting, make sure you like this video, comment, and share this video to your friends for more understanding. I will see you in my next class. Bye bye.